Welcome to the Experience Center. I'm Sturtzel. I'll be talking about audio synthesis today, sort of what it is and what about sound in general. Most of it I'll be referring to this oscilloscope, which is showing the signal from synthesizers. So I'm just going to start. Basically, the most essential element of the audio signal in this context is voltage, and that change in that voltage is what makes basically everything. Right now, you see this very slowly oscillating voltage, which that's just the sound of that voltage changing slowly. But when you speed that up, eventually, it starts to become something that's more like noticeably recognizable as a sound, right? So the human hearing range is generally from about 20 hertz, which this is, you can see about 30 hertz, to about 20,000 hertz. So with that voltage, what I was talking about earlier, there's two different types. Audio rate, which is this. And then control rate, which you can kind of consider that very slow signal control rate, or control voltage. So we did that already. Let's get this back. So control voltage is different in that you use it to modulate different parameters of the sound. Right now, this is just a static sine wave. It's kind of boring, right? But if we use some control voltage, start affecting some change. So that's sort of the basic elements, right? Is that frequency, which is what's being changed right now by that envelope. Amplitude, which I'll show now. If you remember, so if you listen, hear that change, right? Adjust some things and use that same signal to adjust other stuff, specifically amplitude, which is kind of one of the other basic elements. So amplitude is kind of the volume, right? The difference between the high and the low. So if I turn that up slowly, you can see that same signal. Turn that down a little. The sine wave is getting louder, right? And becoming more apparent, taking on more of its sine wave kind of characteristics. So that same concept of amplitude can be applied to control signals as well. So if I do that same modulation of the amplitude with a low frequency oscillator, which is just another way of generating a control signal. We can feed that through something that will change the amplitude of that control signal. And it starts to become a more dynamic sound, right? The signal that is controlling the amplitude is being controlled in its amplitude. So that's sort of what all of this is right? It's a bunch of basic elements that are combined to create something more complex and more interesting. And you can kind of break down any sound into those component parts to synthesize it. Sometimes it's just fun to synthesize for its own sake. Continuing on with this, one of the main methods of synthesis that pops up in music generally is subtractive synthesis, right? So it's trickier when I'm trying to talk and just do this at the same time. So that's where you take several different waveforms. That basic sine wave, in this case, I'll add a triangle wave to it. And again, make something more complex out of composite parts. So that's the sine wave that we started with. And a new sound, right? A triangle wave. There's a bunch of other different wave shapes that are pretty common. A ramp, which goes from high to lower, low to high. A square wave, which is just basically off and on, but really fast. Let's stick with the triangle. Yep. So now we have those two sounds combined together, and it's really common for that to be filtered, right? So that you have different aspects of those sounds at different times. So a filter is exactly what it sounds like. You're putting something into it and then removing things from it, hence the subtractive synthesis, right? So the first one that I'll show you is a low-pass filter, which a lot of filters are also used in electronics in general. These are the exact same kinds of filters, just used in an audio application. So low-pass, you can set the frequency above which you don't want anything. It's just everything below it. So because our sine wave is lower, you pretty much just hear the sine wave when it's at that lower frequency. But as we turn the cutoff up, you get parts of that triangle waveform. So high pass is similar, but the opposite. You start around where that triangle wave is, you get mostly just the triangle. And as you go lower, more aspects of the sine wave get brought in. The third commonly used one is a bandpass, which is basically a window that moves throughout the frequency range. So that's kind of the basics of subtractive synthesis, which is one of the more common modes. There's also additive synthesis, which is kind of built on frequency modulation, which is sort of what I was doing earlier with that, my first example of changing the pitch. Let's get back to that. It's very slow right now, but there's one oscillator that's being modulated by the other one, the oscillator. Right now it's kind of like, yeah, this is super, like, whatever, this is kind of boring and obnoxious. But it gets more interesting when you bring it into audio range. Way more interesting and important in this is the ratios of the frequencies between the two oscillators. I'm going to switch this over to this synth. So those frequency modulated sounds can be pretty chaotic and big and gross sounding, but they're actually super useful for all kinds of things, especially musically. Like bells are really commonly a very common application of techniques. So on this one I have several different fairly common ratios between the two oscillators. The first one is 0.5, so the one oscillator is at 440 hertz, which is middle A, you're musically inclined, and then the other is at 220, so exactly half of that. So that's more, it's cleaner because they line up, right? It's like an even division. That one is a little messier, right? That was actually, so that's more of actually just the frequency modulated. So you hear it if I just. So the difference between that sound, where it's just the static voltage again, is, or the static sound, is the change, the modulation, and adding frequency modulation at the beginning of the sound, and then tapering it off with the envelope that makes the sound apparent, leaves you with those like bell-like sounds, right, where it starts clangy and gets cleaner. that's with it just same throughout. And then getting moving towards the end. Let's see. So yeah, basically combining those simple elements into more complex things. That's how all the sounds that you hear in synthesized music or in synthesized audio in movies, and that's how that's all created. There's a lot of different techniques. Those are kind of just two of the more prevalent ones that are out there all the time. Yeah, thanks.